So here's some ideas about even and odd functions. A function is an even function if f of negative x equals f of x for all values of x. Now this is a way of proving a function is even. Now we know that even functions, we talked about this in class, are symmetrical to the y-axis. Like x squared, y equals x squared, that's an even function. I can maybe look at this over here. We know that y equals x squared is just a parabola. And that's symmetrical to the y-axis. In other words, the right side looks like the left side if I drew it better. All right? Excuse my freehand drawing, but it would be symmetrical to the y-axis. In other words, the right side would look like the left side. And if we set up a mirror at the y-axis, then this will reflect right across there. So that's what the value of knowing what an even function is, or when a function is even, is knowing that it's going to be symmetrical to the y-axis. So if you got some points over here, you could just reflect those points. You don't have to find new points. You can just reflect these points over on this side. You get it like a 2 for 2 points for the price of 1. Now we can formally prove that by using, again, this definition. F of negative x equals f of x. So let's take a look at an example. 3x to the fourth minus 5x squared plus 7. So I can look at this and I know that this is going to be an even function. Now, remember, it's real easy to see that is you just check all your exponents. If all your exponents, if we have polynomials, that is, all you have to do is check all the exponents, and the exponents are all even numbers. It's an even function. Now, you might say, well, what about this? Well, isn't that the same thing as times x to the 0? Because x to the 0 is 1, isn't it? So, even number, and 0 is an even number. So, these are all even exponents. We don't write this because this is 1, but it's always understood to be there. X to the 0 is 1. So those exponents are all even exponents. It's a little trick. It also works for odd functions and shows you when we have a constant there, it's not an odd function. We'll show you that later. Okay, so let's use this definition. So what we're going to do is we're going to try to find f of negative x. And that equals, let me do this in a different color, it might make a little more sense here. So every time I see an x, I'm going to put a negative x. So it's going to be 3 times negative x to the fourth minus 5 times negative x squared plus 7. All right, so this is f of negative x. Every time we see an x, we put a negative x. And then we'll work this out. Now, this is going to be 3 times, and a negative to the fourth power is a positive, so that's just going to be 3x to the fourth minus 5, and x squared, a negative x times negative x is positive x squared, so just x squared plus 7. But this is the same as this. So that's equal to f of x. So what we've shown is that f of negative x equals f of x, so that satisfies the condition. Okay, I hope that makes sense. It's pretty easy. Just kind of square it out. And like I said, when you look at these polynomials, you can just think of this as times x to the 0, and they're all even powers, so it's an even function. Okay, now a function is an odd function if f of negative x equals negative f of x for all values of x. Now this is a function that's symmetrical to the origin. And a nice common one is just y equals x. That's an odd function. And y equals x is just this diagonal line, and you can see how it's symmetrical to the origin. In other words, if we had a mirror and just set it up, don't have a mirror, of course. I'll just use a little paper clip here. And if I just set this paper clip on the origin, you can see how on one side it's just like a reflection of the other side. In other words, you can see over here This side is just reflected on this side. So it's symmetrical to the origin. So odd functions are symmetrical to the origin. So how would we prove such a thing? Well, let's see here. Let's find out what f of negative x is. So every time I see an x, I put a negative x. So I got 2 times plus 4 times negative x to the third. And then if I power these out, I've got 2 times. And what's a negative x to the fifth? Well, if we raise a negative to an odd power, it's going to be negative, so it's going to be negative 2x to the fifth. And again, a negative to an odd power, a negative times a negative is a positive times a negative is a negative, so it's going to be negative 4x to the third. But what we can do is we could factor out a negative sign out of both these, so it's going to be negative times. Then we've got 2x to the fifth. Excuse me. If I take out a negative, that's going to be positive 4x cubed. But that looks just like this. That's f of x. Okay. You can see that 2x to the fifth plus 4x cubed, 2x to the fifth plus 4x cubed, that's f of x, and we got a negative. So I've shown that f of negative x equals negative f of x. Guess I could write it down over here. Oops, let me write that, show you that there over here. Excuse me, got off my frame there. And then if we go back and look at the first example, we can say that f of negative x over here equals f of x, and we have even function. Okay? So there's odd and even functions, and I'm going to give you some examples of neither on the next video. That'll be number 2.